Hello everyone. Our next concept is Thevenin's and Norton's theorem. Okay, the definition of Thevenin's and Norton's theorem is in a linear bilateral network, when many sources acting simultaneously, then entire network is replaced by ideal voltage source in series with impedance in case of Thevenin's theorem. In case of Norton's theorem, entire network is replaced with ideal current source in parallel with impedance. Okay. For suppose this is the network, that means linear bilateral network. Okay, this network contains many sources and many impedances. This entire network can be replaced with single voltage source in series with single resistance or single impedance. This is called Thevenin's network or Thevenin circuit. Okay, this is RL. Or for suppose if this network is replaced with ideal current source in parallel with resistance. Okay, if it is Thevenin circuit, we need to replace this entire network with ideal voltage source in series with resistance. If you want to find out Norton equivalent, entire network is replaced with ideal current source in parallel with resistance or impedance. Okay, for suppose if you find Thevenin equivalent for this network, if you want to find out network Norton equivalent, then just simply apply source transformation for this one. So what is I Norton now? I Norton is equal to V Thevenin by R Thevenin, and R Norton is equal to R Thevenin. For suppose if you find Norton equivalent from this network, and from this if you want to find out Thevenin equivalent, just simply replace this with V Thevenin and R Thevenin by applying source transformation. That is V Thevenin is equal to I Norton into R Norton. Here also R Thevenin is equal to R Norton. Based on the type of sources present in the network, Thevenin's theorem can be categorized as follows: three cases. Case 1, if network contains only independent sources. Case 2, if network contains both independent and dependent sources. If network contains only dependent sources. What will happen in these three cases, we will see. For suppose this is the network and this is load resistance RL. If you want to find Thevenin equivalent for this network, or if you want to find Norton equivalent for this network, then just open this load resistance RL. Open this load resistance or load impedance RL. Then find VOC. Okay, this is open circuit. If you find voltage across these terminals, these two terminals, it is open circuit voltage, that is VOC. This is V Thevenin. This is V Thevenin. So you will get VOC is equal to V Thevenin. For suppose if you want to find out Norton equivalent, short these two terminals and find ISC. Short these two terminals and find ISC. ISC is equal to I Norton. VOC is equal to V Thevenin, ISC is equal to I Norton. For suppose if you want to find out Thevenin resistance or Norton resistance, both are equal. This is open circuit. Find the resistance across these two terminals, open circuit resistance. Okay, this is ROC. ROC is equal to R Thevenin, that is equal to R Norton. Or from these two values, R Thevenin or R Norton is equal to V Thevenin by I Norton. You can solve by using V Thevenin I Norton or by using ROC. Now we will solve some problems on this concept. First question is find the Thevenin's equivalent across the AB for the following network. This is the given network. So he is asking Thevenin equivalent across these two terminals. Okay, here already load resistance is open circuit. That is load resistance is open. Now if we want to find out Thevenin equivalent across these two terminals. So first thing is open circuit voltage. Okay, here it is VOC is equal to VAB is equal to V Thevenin. So this VOC, VAB or V Thevenin is open circuit voltage is same as this node voltage. This is V Thevenin, because for suppose let it be V1. Okay, here it is open circuit. If it is open circuit, what is the current flowing through this? I is equal to 0 amps. I is equal to 0 amps. So by KVL for this loop, Okay, let it be V1. V1 is equal to, so the voltage across this resistor is 3 into I, and voltage across these two terminals is Thevenin. I is 0, so what is V1? Thevenin. So if I is 0, Thevenin is V1. These two terminals are open circuited. This node voltage becomes this voltage. So that is Thevenin. Apply nodal analysis at Thevenin. So what you are getting? So if you write node equation for this one, so Thevenin minus 10 by 2 plus, so this current is coming towards to this node, so it is minus 3. So this is open circuit, or you can write I equal to 0. So this is 0 equal to 0. If you solve this, you will get Thevenin is equal to 16 volts. Now we want to find out Thevenin. So to find Thevenin, all ideal voltage sources are replaced with short circuit and all ideal current sources are replaced with open circuit, because whenever we want to find out the resistance, replace voltage source and current source with their internal impedances. The internal impedance of ideal voltage source is 0. The internal impedance of ideal current source is infinity, that is open circuit. If you replace internal impedances, you will get circuit becomes like this. Okay, this is Thevenin, and this is 3 ohms, and this is 2 ohms. Now what is Thevenin? 3 ohms and 2 ohms are in series, so Thevenin is equal to 2 plus 3, this is 5 ohms. So the Thevenin equivalent becomes like this. For suppose if you want to find out Norton equivalent, so Thevenin is equal to R Norton. No need to find R Norton specially. Now apply source transformation for this one. So you will get I Norton is equal to V Thevenin by R Thevenin. So what we are getting? 16 by 5, 3.2 amps. This is Norton current. So the Norton equivalent becomes like this. Okay, this is the Thevenin equivalent and this is the Norton equivalent. Next question is, find the Norton's equivalent across the AB for the following network. Okay, this is the given network, same as previous network. So to find Norton equivalent, first find the Norton current. Norton current means short circuit current. So short the terminals AB. This is ISC, that equal to I Norton. Okay, to find this I Norton, let it be V1. Write the node equation for V1. So what you are getting? V1 minus 10 by 2. So this current is coming towards to this node. So this is minus 3 plus V1 by 3 is equal to 0. So 3V1 minus 30 minus 18 plus 2V1 is equal to 0. So if you solve this, V1 is equal to 9.6 volts. Okay, now I want to find out this Norton currents. So by Ohm's law, what is Norton current? IN is equal to V by R. So V1 by R. What is V1? V1 is 9.6. R is 3. Okay, in this branch, this is 3. So we will get 3.2 amps. So what is I Norton? I Norton is equal to 3.2 amps. Now to find R Norton, the procedure is same as Thevenin. All independent voltage sources are replaced with short circuit. All independent current sources are replaced with open circuit, because the internal impedance of voltage source is short circuit 0. The internal impedance of current source is infinity, that is open circuit. So now circuit becomes like this. Again, these 3 ohms and 2 ohms are in series. Okay, these 2 ohms and 3 ohms, 2 ohms are in series. So what is R Norton? R Norton is equal to 2 plus 3, that equal to 5 ohms. So circuit can be represented like this. I Norton is 3.2 amps and R Norton is 5 ohms. So to get Thevenin equivalent, what we are doing? Apply source transformation. So what is source transformation? Thevenin is equal to I Norton into R Norton. So 3.2 into 5, you will get 16 volts. So Thevenin is equal to R Norton. So by applying source transformation, we will get both the circuits. In the next video, we will solve some more problems. Thank you for watching.